Hello everyone, this is Mr. Shah. Today we're going to talk about the atomic emission spectrum as part of section 5.3, chapter 5, section 3, part 1. We're going to be talking today about light and how light occurs. So your objective for today is to be able to explain what causes the atomic emission spectrum. So what actually causes the atomic emission spectrum? Studies of the new quantum mechanical model for the atom led scientists to believe that light consists of waves. But what is a wave? We show a wave through this squiggly line on the x-axis. So we have the x-axis here, and then there's this wave going along it. The wave has a bunch of different parts. It has a crest, which is the top part. When it goes above, it makes this hump. There's a trough, which is the bottom sort of hump part of the wave. The height from the x-axis to the crest is called amplitude. Okay, and the distance between one crest to a second crest is the wavelength. The wavelength is shown or represented through the Greek letter lambda. It's a Greek letter and we call it lambda. There are many different types of waves, and they're characterized by either low frequency or high frequency. But before we talk about the difference, we should talk about what frequency is defined as. Frequency, which we represent as this italic V, is the number of wave cycles to pass a given point per unit of time. So if we had maybe 1 minute of time for each of these waves, a low frequency wave would have less wave cycles, and one wave cycle is really one wavelength, one full wavelength. So a low frequency would have less wavelengths or wave cycles or shorter wavelengths, while a high frequency has higher wavelengths or higher wave cycles in 1 minute in any given amount of time. So how do we actually calculate wavelength or frequency? There's an equation. The equation is C equals lambda times B. C is a constant, which is actually the speed of light. That's our constant. Lambda is our wavelength. I should spell it right. While this V is our frequency. So you can use those variables to find something that's missing. What is electromagnetic radiation? That's part of our atomic emission spectrum discussion. Electromagnetic radiation includes radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. All those things we've talked about before. All electromagnetic waves travel in a vacuum at a speed of light of 2.998 times 10 to the 8th meters per second. So this is your constant for that previous equation. So let's summarize what we've talked about so far. Light travels as waves. Waves have a wavelength, frequency, and amplitude on a graph. On the visible light spectrum, red has longer wavelength and lower frequency and low energy, something you should write down in your notes to remember. Blue has shorter wavelength, high frequency, and high energy. What actually causes the atomic emission spectrum? So going back to our original question. The atomic emission spectra is what we see here, okay? It's caused by released light of certain wavelengths. We'll get into that a little bit more of how that light is released in other sections of the chapter, but for now, the atomic emission spectra is caused by released light of certain wavelengths. If you have any questions, please let me know. Other than that, have a good night.